Apologies, the last video got cut off, so we're looking at question B now, 1b. Let u be equal to 1 minus root 2 and v equals to 2 plus root 2. Find 2 over u minus 1 over v. So our 2 over u will just be equal to 2 over our u value, which is this, so 1 minus root 2, and our 1 over v is equal to 1 over 2 plus root 2. Now, I think the easiest way to do this question is to rationalize both 2 over u and 1 over v individually, and then add them, then subtract them. So in order to rationalize 2 over 1 minus root 2 is to multiply by the conjugate, which is 1 plus root 2. So 2 over 1 minus root 2, so 2 minus u equals to 1 plus root 2 over 1 plus root 2. This equals 2, so we'll look at the denominator first. So 1 times 1 is 1, and we have root 2 times root 2. And that gives us negative 2. Now the numerator, 1 times 2 is 2 plus 2 root 2. Therefore, this will equal to negative 2 minus 2 root 2. Our 1 over v will be equal to 1 over 2 plus root 2 multiplied by the conjugate, which is 2 minus root 2. 2 minus root 2. And this will be equal to 2 times 2 is 4. 2 times 2 is 4, so 4 minus root 2 times negative root 2 is negative 2, so 4 minus 2 is just 2. And we have 2 minus root 2 at the top. And this will simplify to 1 minus half root 2. So now we can subtract these. We can say that negative 2 minus 2 root 2 minus 1 minus half of root 2. So right now we will have negative 2 minus 1, which is negative 3. And we'll have negative 2 root 2 minus 1 half of root 2, which is plus root 2. So negative 2 minus 1, that's negative 3. And negative root 2 plus half of root 2 would be equal to negative 3 over 2 root 2. And that would be your final answer for this question. Yeah, that would be your final answer. Negative 3 minus 3 over 2 root 2. Question C. Solve for 3 plus root of x equals to root of x plus p for x in terms of p. Alright, so right now we have a lot of square roots, and we should our first step is to get rid of some of the square roots. So right now the first step is to square both sides. So 3 plus square root of x multiplied by 3 plus square root of x equals to square of square root of x plus p, which is just x plus p. So if we expand this out, so 3 times 3 is 9, 3 times root x is 3 root x, and we have 3 root x on the other side as well, and then plus root x times root x, which is just plus x, equals to x plus of p. Right now we can see that these two x's will cancel out. So you have 9 plus 6 root x equals to p, and you're looking for an equation of x in terms of p. So right now the easiest way to do this is to move the 9 to the other side and just leave 6 root x by itself. Because if you square it right now, let's say you square it right now, you end up with a lot more a lot more different terms that will just not be great. So if you move the 9 to the other side first, you'll just be left with 6 root x, which is extremely easy to square, which just becomes 36x. So if you move 9 to the other side, you'll have less terms to deal with than if you just square it right now. So your 6 root x equals to p minus 9. Therefore, 36x is equal to p squared minus 18p plus 81. So therefore, your x value is equal to p squared minus 18p plus 81 over 36. Question D. Solve square root of 2x equals to x minus 4. So right now we have the square root here. We want to get rid of it by squaring both sides. So 2x equals to x squared minus 8x plus 16. Therefore 0 is equal to x squared minus 10x plus 16. 0 equals to x minus 8, x minus 2. So therefore x equals to 8, x equals to 2. However, when you square the left side, you actually create a different quadratic equation, which creates an untrue solution. So one of these should be invalid solution, so we have to test. So let's say we're testing x equals to 8 first. So if we're testing x equals to 8, then we'll have square root of 16 equals to 8 minus 4. And therefore 4 equals to 4. This is a valid solution. However, if you're testing test x equals to 2, then you have square root of 4 equals to 2 minus 4. So we have 2 equals to negative 2, which is obviously not correct. So this is an incorrect solution. So therefore, x is only equal to 8. And you have to do this, you have to eliminate a solution to get the full mark for this question. Alright, question E. We're going to be solving for square root of x plus p plus square root of x minus p, a whole thing over square root of x plus p minus square root of x minus p equals to 4. To do this question, we should just, first thing, we should multiply both sides by the denominator. So we have square root of x plus p plus square root of x minus p equals to 4 times of square root of x plus p minus square root of x minus p. Now if we expand the right side of the equation, we'll get square root of x plus p plus square root of x minus p equals to 4 square root of x plus p minus 4 square root of x minus p. Alright, so for this equation right now, we can actually move the left side to the right side, and because this is, for example, this is just 1 square root of x plus p, and this is just 1 of square root of x minus p. So if we move, for example, if we move square root of x minus p to the other side, it becomes minus square root of x minus p. And right now you have 4 square root of x minus p. If you minus square root of x minus p over here, it will just become negative 5 square root of x minus p, because this thing is same as this term here. So you can just subtract the coefficients right here. So right now we can move everything to one side of the equation. So 0 equals to 3 of square root of x plus p minus 5 square root of x minus p. Now we'll move one of the terms back, doesn't really matter which one, but for the sake of positivity, I'll move the negative 5 over. So 5 square root of x minus p equals to 3 square root of x plus p. Now we just need to square both sides, so 25 times x minus p equals to 9 times x plus p. 25x minus 25p is equal to 9x plus 9p. And we were looking for x in terms of p. So x in terms of p, so we'll have 16x equals to 34p. And therefore we will have, which one? So x in terms of p, so we'll have x equals to 34 over, what am I doing? 34p over 16 is equal to x, and if we simplify it, we'll get x equals to 17p over 8. And that's your final answer for this question. Question 2a. Solve for 3x squared minus 2x minus 4, and leave answer is a plus b squared over c. So for this question, we can just use a quadratic formula in order to find our answer. So it's negative b plus or minus square root of b squared minus 4ac over 2a. So we'll have 2 plus or minus square root of b squared, which is 4, minus 4 times of a, which is 3, times of c, which is 4. So whole thing over 6, which is 2a. This equals to 2 plus or minus square root of 4 times negative 3 is negative 12. Negative 12, that becomes negative 48. So this becomes, because double negative makes a positive, becomes 4 plus 48 inside the brackets, which makes it 2 plus or minus 52 over 6. Alright, so we can simplify this even further. We can say that this 2 plus or minus square root of 52, which can be simplified. So square root of 52 can be simplified to 4 times 13. And if we can square root the 4, which will leave 2 on the outside. So 2 plus or minus 2 square root of 13 over 6. And hence this will be equal to 1 over 3 plus 1 over 3 root 13. And that should be your final answer for this question, because square root of 13 cannot be simplified anymore because it is a prime number. Alright, so 3b. U equals to 10 plus 5i and v equals to 4 plus ki. Find the value of k if u equals to 1 plus 2i times of v. So our u value is equal to 10 plus 5i. So therefore we can substitute this u as 10 plus 5i. So we can say 10 plus 5i equals to 1 plus 2i times of v. V is this value here, so we can say substitute this v here for this value here. So we'll say that this is 4 plus ki. If we simplify this, we'll get 10 plus 5i equals to, we just expand this, so 1 times 4 is 4, 1 times ki is ki, 2i times 4 is plus 8i, 2i times ki is 2ki squared, I squared is negative 1, so this becomes negative 2k. Alright, so we were looking for, what was the question asking? Find the value of k. To find the value of k, we can make the imaginary part equal to the imaginary part and the real part equal to a real part. So as you can see here, so this 4 and this 20 and this negative 2k, these two are real because they do not contain I, and these two that do contain I must be imaginary. So we can say that 10 will be, the 10 is the real part of the left side, so 10 is equal to 4 minus 2k. And then we'll say that 6 equals to negative 2k, therefore k equals to negative 3. That's your final answer for this question. Question II. Calculate the modulus of uv. So once again, we had u as 10 plus 5i, so we can say we can say that we're trying to find the modulus of 10 plus 5i multiplied by v, which we found, the last answer we found that k is negative 3, so we can say 4 minus 3i. Alright, so in order to find the modulus, we should expand everything inside the modulus first and then find the modulus of whatever is the result. So modulus of 10 times 4 is 40. 10 times negative 3i is negative 30i. 5i times 4 is positive 20i. And 5i times negative 3i, that's 15, that's negative 15i squared. I squared is negative 1, so negative 15 times negative 1, that's positive. So therefore this is plus 15. You will get that this is equal to modulus of 55 minus 10i. So modulus of, for example, modulus of x would be equal to x squared minus x squared plus y squared. So in this case, we'll have the modulus of, uv would be equal to square root of 55 squared plus 10 squared, because negative 10 squared is just equal to positive 10 squared. So this is equal to square root of 3125. And we can actually simplify this, so we can say that this, we can take 25 squared out, so we can take, okay, so let's do this one at a time. So we can take 25 out, so we can say that this is equal to square root of 25 times, calculator. Sorry guys, I totally forgot to bring my calculator. So 3125 divided by 25, so times 125. So modulus uv equals to 5 root 125. So 125 divided by 25 again, so uv equals to 5 times 25 times 5. So therefore, modulus of uv, that looks like vv, I'm saying uv equals to 25 root 5. That's your final answer. Simplified answer. Question C. Determine values of c so that x squared plus 4x minus 1 minus c times of x squared plus of 1 equals to 0 has two real solutions. So two real solutions is b squared minus 4ac is greater than 0. So right now we need to find our a, b, and c values. So right now we will have x squared minus 4x minus 1 minus cx squared minus c. So we know that this is 1x squared at the front here, and this is negative cx squared. So we can factor these together, so 1 minus c multiplied by x squared, and minus 4x minus 1 minus c, that equals to 0. So now this is your a value, this is your b value, and this whole thing is your c value. So b squared, so negative 4 squared is 16 minus 4 times of 1 minus c times of negative 1 minus c. And that will actually get you 16 minus 16. Let me double check this. This will get you that'll get you 4 minus 4c multiplied by negative 1 minus c. And that must be greater than 0. So if we simplify further, we'll have, expanding it out, we'll just have 4 times negative 1 is negative 4, 4 times negative c is negative 4c, negative 4c times 1 is plus 4c, and negative 4c times negative c is negative 4c squared. I believe, so let me double check. Negative 4c. Oh no, yeah, that's positive 4c, sorry, my bad. This is positive 4c squared, and that's positive 4c, positive 4c. Yeah, so this and this will cancel out. So 16 minus 4 is plus 4, and minus 4c squared is greater than 0. So therefore, if we solve this equation, we'll get that c is equal to negative root 5 or root 5. However, we have to look at the shape of this parabola. It's negative 4c squared, meaning it's a negative parabola. So we'll have the shape looking something like this. And we want to find that when it's greater than 0, so this part here. So this is our negative root 5 here, and that's our positive root 5 here. So in between these two values, we will get where we have two different solutions, two real solutions. So therefore, your c value will be between square root of 5 and negative square root of 5. So your c will be greater than negative root 5, but your c will be less than root 5. Okay, I think one important thing, I think it's pretty important to note that when c equals to 1, so where can I write this? Okay, so when c equals to 1, note that it was c minus 1. Was it c minus 1? I cannot remember. It was 1 minus c. So 1 minus c was 1 minus c x squared minus 4x minus 1 minus c, I think. Minus 1 minus c. Note that when c equals to 1, so 1 minus 1 here would be 0. So that means this whole thing is just 0x squared. So it will just be negative 4x, 1 minus 1, so minus 2. You see, this equation will only have one real solution. So just for this specific case, this will have one solution, and this does not meet the requirements. So therefore, you can say that c cannot be equal to 1, because that will result in 0x squared, and therefore you cannot have two different solutions. So D, prove the equation 3x squared minus 2mx plus m minus 1 equals to 0 has real solutions for all real values m. So real solutions is b squared minus 4ac is greater than or equal to 0, and our discriminant is b squared minus 4ac. So we're going to be finding our discriminant. So our discriminant is equal to b squared, which is negative 2m times negative 2n, which is 4m squared minus of 4 times of a, which is 3, times of c, which is m minus 1. Have our discriminant is equal to 4m squared minus 12 times of m minus 1. Our discriminant will therefore be equal to 4m squared minus 12m minus 12. So double negative makes a positive, so 4m squared minus 12m plus 12. That's our discriminant. So we need to prove that the discriminant is always greater than 0. The first thing to look for is this a perfect square? So first thing to look for, is it a perfect square? Okay, so the answer to this question is no, because in order to have a perfect square, so square root of 4 is 2, that's a perfect square, so we can have 2m and 2m. However, this 12 here is not a perfect square, so it's actually not going to work out the way you want it. It's not a perfect square, so you cannot write it this way. So in this case, you're going to have to, number 2, write as the, what was that called again? Completing the square, right? We have to complete the square, and then we have, by completing the square, we can also prove that it's greater than 0. So 2 is complete the square. Okay, so we have those two possibilities. Okay, when you have to prove something is greater than 0. So 4m squared minus 12m plus 12, we write it as a perfect square, which is 2m times of 2m. And 2m times 2m, what equals to negative 12? So we have negative 3 on this side and negative 3 on this side. The reason it's negative 3 is because there's a factor of 2. So negative 3 times 2 is negative 6, and negative 3 times 2 is negative 6. Negative 6 minus negative 6 minus 6 is negative 12. So that will be your perfect square, and plus c will be equal to 4m squared minus 12m plus 12. So if we expand this out, we'll get 4m squared minus 12m plus 9 plus c equals to 4m squared minus 12m plus 12. And therefore, our c value must be 3. So therefore, you'll have your perfect square, which is 2m minus 3 squared plus 3 is equal to your discriminant. As you can see here, any number squared must be a positive or equal to 0, and your plus 3 will definitely make it a positive. So you can say that 2m minus 3 squared must be positive or equal to 0. Plus 3 is positive, hence discriminant greater than 0. Greater than 0, hence there are real solutions. So that would be your final answer for that question. Question E, if z equals to a plus bi and z plus 2 over z is real, prove that the modulus of z is 2, square root of 2, and z is real. So for this question, we have our z equals to a plus bi, and we know that z plus 2 over z is real. So first things first, we want to evaluate z plus, we want to evaluate z plus 2 over z. So we have z, which is a plus bi, plus of 2 over a plus bi. Okay, so for this question, it is best to rationalize this 2 over a plus bi first. So you want to rationalize it by multiplying by the conjugate. So a plus bi plus of 2 over a plus bi times of a minus bi times a minus bi. So a plus bi plus of a times a is a squared, b times negative b is negative b squared. However, I squared is negative 1, so negative of negative b squared is positive b squared over 2a minus 2bi. Alright, so now you have your abi, a plus bi plus of a squared plus b squared over 2a minus 2bi. So right now, you want to for this a plus bi, you want to multiply it, so it has the same denominator, so multiply by a squared plus b squared. So if I move to the next page here, so a plus bi times a squared plus b squared over a squared plus b squared, plus of, what was it again? Plus of 2a minus 2bi. 2a minus 2bi over a squared plus b squared. Alright, so expanding the left side of the equation, we'll have a cubed plus ab squared plus a squared bi plus b cubed I. And we'll add that on to that's over a squared plus b squared plus 2a minus 2bi over a squared plus b squared. So therefore this will be equal to a to the power 3 plus ab squared plus a squared bi plus b cubed I plus 2a minus 2bi over a squared plus b squared. Okay, so a lot of people get stuck on this stage, okay? However, one important information we have is that we have, was it real? We know that z plus 2 over z is real. So therefore, the imaginary part of this complex number, imaginary part of this z plus 2 over z must be equal to 0. There's no imaginary part, therefore it's real. So with this part of the equation, we will group all the real parts together and all the imaginary parts together. So our real parts would be the a3 here, a to the power 3, our ab squared, and our 2a. So a cubed plus, a cubed plus ab squared plus 2a over a squared plus b squared. That's our real part. And we have our imaginary part. Our imaginary part would be a squared bi, b cubed I, and negative 2bi. So we can just take the I out for now. So we say a squared b plus b cubed minus 2b over a squared plus b squared I. Okay, so this part here, that's your imaginary part of z plus of 2 over z. So we know this part, this imaginary part must be equal to 0. So a squared b plus b cubed minus 2b must be equal to 0. We notice that we can divide everything by b. So a squared plus b squared minus 2 equals to 0. So therefore, a squared plus b squared equals to 2. So remember at the very start we had our z equals to a plus bi. So therefore, the modulus of z would be equal to square root of a squared plus b squared. And voila, we have a squared plus b squared equals to 2. So automatically we can say modulus of z equals to square root of 2. That is already proved. The second part of the question asks you to prove that z is real. Okay. In order to prove that z is real, we can look back at this equation here. So a squared b plus b cubed minus 2b. That equals to 0. In order for this equation to be equal to 0, as you can see, this common term b must be equal to 0 in order for everything to cancel out to be 0. So therefore we know that b equals to 0. Remember we had our z equals to a plus bi, and we proved that b equals to 0. So it will be z equals to a plus 0i. So therefore z equals to a. A is real, therefore z is real. So we can say a is real, hence z is real. And that would be your final answer for this question. Alright, so we're looking at question 3 now. So let u be 4 plus I and v be 3 minus 2i. So 2u minus 3v, finding it. So 2 times of 4 plus I minus 3 times of 3 minus 2i. So 4 times 2 is 8, 2 times I is plus 2i, minus negative 3 times 3 is negative 9, negative 3 times negative 2i is positive 6i. So grouping the like terms together, we'll have 8i minus 1. Done. Simple. Done. I will find u over v and the modulus of u over v. So u was 4 plus I and v was 3 minus 2i. So 4 plus I over 3 minus 2i. That is equal to u over v. So right now we want to find u over v, which means we have to rationalize the denominator by multiplying by the conjugate. So 3 plus 2i, 3 plus 2i. This equals to 9. Negative 2 times negative 2 is negative 4. I squared is negative 1, so it becomes plus 4 over 12 plus 8i plus 8i plus 3i plus 2i squared, which becomes negative 2. So this becomes 10 plus 11i over 13. So therefore 10 over 13 plus 11 over 13. Alright. So we want to find the modulus of u over v. So therefore, modulus of u over v equals to square root of 10 over 13 squared plus 11 over 13 squared. Alright, so right now we can expand this. So modulus of uv equals to square root of 100 over 169 plus 121 over 169. This equals to square root of 221 over 169, and this equals to square root of 221 over 13. So square root of 221 cannot be simplified, so therefore this is your final answer. That's the answer in the simplest form, because 221 cannot be factored into square numbers. Question B, write 2 over 3i plus I over I minus I in the form p plus qi with p and q as real numbers. Okay, we'll start up here. So we'll say 2 over 3i plus I over 1 minus I. Alright, so in this case, I just directly cross multiply straight away, because 3i and negative I is going to cancel out. So we'll say this equals to 3i minus 3i squared, which is plus 3, over 2i. So right now we want to be multiplying by the conjugate in order to rationalize the denominator. So this will be multiplied by 3i minus, wrong way. This will be multiplied by negative 3i. Remember to always change the sign of the imaginary term. So 3i plus 3, negative 3i plus 3. This equals to negative 3i times 3i is positive 9. And 3 times 3 is 9. And this will be, the numerator will be 2i times negative 3i, which is positive 6 plus 6i. I believe I did not mess up. So 3. I might have typed. Oh, sorry. I've done something very wrong. Sorry, guys. Sorry, guys. I have messed up badly. Apologies. So, as normal, we're going to do our denominator. Our denominator is 3i squared, which is 3 plus 3i. However, our numerator is 2 times of 1 minus I plus 3i squared, which is negative 3. So 2 minus 2i minus 3 over 3 plus 3i. So therefore this is equal to negative 1 over minus 2i over 3 plus 3i. So right now we're going to rationalize it as we were doing before, but we were doing it wrong before. So negative 1 minus 2i over 3 plus 3i multiplied by 3 minus 3i, 3 minus 3i. This equals to 9 plus 9 over 3. Negative 3, sorry, that's negative 3. Negative 3 plus 3i minus 6i plus 6i squared. So 6i squared is negative square root of I squared is negative 1, so minus 6. Whew, okay. So right now we will have negative 3i minus 9 over 18. Therefore, this is equal to negative 1 over 6i minus 1 over 2. That is your final answer. And that is your final answer. That is the correct answer. Alright, question C. Determine the complex number z equals to x plus iy that satisfies 2z minus I times the conjugate of z equals to 5 minus zi. So, our z equals to x plus iy, and therefore 2 times of x plus iy minus I times, our conjugate of z equals to x minus iy. So, times of I times of x minus iy equals to 5 minus 7i. So 2x plus 2yi minus ix. negative I times negative I is positive I squared, which becomes negative 1. So that's negative y equals to 5 minus 7i. So remember how I was talking about the real part equals to the real part and the imaginary part equals to the imaginary part. We're going to use the exact same idea here. So 2x and negative y is... Sorry, what am I saying? 2x and negative y is real. So 2x minus y equals to the real part, which is 5. And we have the imaginary part, which is 2y and negative x. So 2y minus x equals to negative 7. Now we just need to solve for... really. So right now we will have 5 minus 2x equals to negative y. So therefore y equals to negative 5 plus 2x. And if we substitute into this bottom equation, we'll have 2 times of 5 plus negative 5 plus 2x minus x equals to negative 7. So negative 10 plus 4x minus x equals to negative 7. 3x minus 10 equals to negative 7. 3x therefore equals to 3, x equals to 1. And if x equals to 1, then we substitute back into this equation. So 1 times 2 is 2. 2 minus y equals to 5. So 2 minus negative 3 is 5. So therefore y equals negative 3. That is your final answer. This is the correct answer. And therefore, we write our final complex number. So our final complex number will be z equals to... Our x value is 1, so our x value here is 1, so 1, and our y value here is negative 3, so minus 3i. Done. And I have the last 2 questions on a separate PDF because I ran out of space. And here oh, okay, we're almost done, guys. We're almost done. So we have in this question we have to find the modulus of z1 times z2 over z1 plus z2. So z1 is equal to negative, z1 is equal to 2 minus 3i, and z2 equals to negative 1 plus i. So 2 minus 3i times of negative 1 plus i over 2 minus 3i plus negative 1 over I, which is negative 1 plus I. And we're trying to find the modulus of this. Therefore, our denominator will simplify to negative 3i plus I is negative 2i. 2 minus 1 is just 1. So on the top, we will have 2 times negative 2 is negative 2, plus 2 times I, which is 2i, plus of negative 3i times negative 1 is plus 3i, and negative 3i times I is negative 3i squared, which is plus 3. So this is equal to 1 plus 5i over negative 2i plus 1. Negative 2i plus 1. And then we need to multiply by the conjugate in order to get rid of the I in the numerator. So 2i plus 1 over 2i plus 1. This is equal to negative 2i. So 1 times 1 is just 1. And 2i times 2i. What am I doing? So negative 2i times 2i, that's negative 4i squared, which is plus 4, over 1 times 2i is 2i, 1 times 1 is just 1, 5i times 2i is 10i squared, which is negative 10 plus our 5i. So this is equal to 7i plus 9 over 5. Whew, okay, we're almost there, guys. Okay, so 7 over 5i plus 9 over 5. I'm trying to find the modulus of this. So this is equal to square root of 7 over 5 squared plus 9 over 5 squared. This is equal to square root of 49 over 25 plus 81 over 25. And this equals to 130 over 25 square root. And therefore this equals to a square root of 130 over 5. Square root of 130, this cannot be simplified into any more square numbers, so this is your simplest form. That's your final answer. So question E, okay, we're almost there. I'm getting really tired, so we're almost there. Let z equals to 3 minus I over 2 plus pi if the real part of z equals to 1/2. Find the values of p. So first things first, once again, we gotta rationalize the denominator. So we've got to multiply by the conjugate. So if z equals to 3 minus I, 2 plus pi, multiplied by 2 minus pi, 2 minus pi. So this equals 2 times 2 is 4, p times negative p is, and then I, so that becomes negative p squared I squared. I squared is negative 1, so it becomes positive p squared. 3 times 2 is 6 on the numerator. 3 times negative pi is negative 3 pi. Minus I times 2 is minus 2i. And then we have negative p times negative I, and that becomes positive, so pi squared, which becomes negative p. So we have 6 minus p minus 3 pi minus 2i over 4 plus p squared. So now we can split this into the imaginary parts and the real parts. So this part here is real, and this part here is imaginary. Okay? So 6 minus p over 4 plus p squared minus 3p plus 2 over 4 plus p squared times of I. So we know that this real part here is equal to 1/2. So now we can just solve for p. Really easy now. Okay, so 1 over 2 is equal to, where's my, go away, equals to 6 minus p over 4 plus p squared. If we move the denominator to the other side, we'll get 2 plus 1/2 of p squared equals to 6 minus p. Therefore, we'll have 1/2 of p squared minus 4 plus of p equals 0. So now you can just go to your graphics calculator. Oh god, I'm so tired. Oh, gosh, so you have 0.5, you have 1 and negative 4. So you have your, then you'll get your p values. P is equal to 2 or p equals negative 4. And that's it. That's your final answer. You're done. That's excellent question right there. Okay. So thank you for watching this video. Okay. Hope you enjoyed, and I hope to see you on the next video.